Are you stuck in the NCERT Exemplar Chapter 2? Don't worry, I have the easy solution for you. Now here the solution of MCQ, numerical, short answer type question, very short answer question and long answer question. I have compiled a step-by-step solution for you which helps you understand better and solve the numerical or MCQ in different types of examination. This solution extremely helpful for you to score good marks in your coming examination. Okay? Now, with my resource, you will be able to solve trickiest numerical request problem with ease. Okay? Please like, share and comment on it. And if you are new, subscribe my channel to get the good score in your incoming examination. Okay? Now let's start. Now question number 2.1. The number of significant figures in 0.06900. Okay? Now this is the numerical related to significant figure. Now rule of this numerical: for decimal number trailing zeros are significant and zeros in left of non-zero digits are not significant. So look at this, here 6 significant, 9 significant and these are significant. So number of significant figure is 4. Okay. Now question number 2. The sum of the numbers 436.32, 227.2 and 0.301 in appropriate significant figure. So look at this. This MCQ related to arithmetic operations. For addition or subtraction, the number of decimal places in the result is the number of decimal places of a number having least decimal places. So look at this. Here decimal places 2. Here decimal places 1. Here decimal places 3. So result have only 1 decimal places. So look at this. The 1 decimal places have only C. So C is the correct option. Now question number 2.3. The mass and volume of a body are this and this respectively. The density of the material of the body in correct significant figure. This also based on arithmetic operation. Look at this. Here number of significant figure is 4. Here number of significant figure is 2. Okay. So in division and multiplication, the number of significant figure of the result is equal to the number having least decimal figure. So look at this. Here least decimal figure is 2. So result also have 2 significant figures. Now look at this. C option has 2 significant figure. So C is correct. Okay. Now look at this. The numbers this and this on rounding of 3 significant figures will give. Look at this. If we see, look at this. If we rounding 35, 45, if we rounding 3.5, 4.5, 5.5, 6.5 into a 1 decimal places, then look at this. If odd number is present, if odd number is present before the 5, so 1 addition takes place. So this is the 4. If even number present, no addition takes place. This also 4. Look at this, or odd number present. This is the 5 plus 1. So this is the 6. This is the even number. This is only 6. So look at this. Here before 5 there is even number. So look at this. This becomes 2.74. Now before this there is a 3 odd number. So this also 2.74. So look at this, option D is correct. Okay. Now question number 2.5. The length and breadth of a rectangular sheet are 16.2 centimeter and 10.1 centimeter respectively. The area of the sheet in appropriate significant figure and correct error. Now look at this, here significant figure is 3. Here significant figure is also 3. So result also have 3 significant figure. Now look at the answer. Look at this, here only this option has 3 significant figure. So this option is correct. Okay. Now look at this. This is the 2.6. Which of the following pairs of physical quantities does not have the same dimensional formula? Look at this, work and torque both have dimension. This is the ml squared t minus 2. Angular momentum and Planck's constant both have dimension. This is the ml squared t minus 1. Surface tension has surface tension and tension have different dimension. Tension have dimension. This is the ml t minus 2, that is the force, and surface tension dimension force by length ml t minus 2 divided by l. This cancel out. So this is the ml t minus 2. Okay. Now question number 2.7. Measure of two quantities along with the precision of respective measurement of respective measuring instrument is. Look at this. This is the 2.5 meter per second and error is 0.5 meter per second. This is the second and this is the error in measure and error in measurement of time. Okay. The value of AB will be, look at this, suppose y equal to A into B. So look at this, the relative error of y is equal to, this is the relative error of A plus this is the relative error of B. Okay, no problem. Now look at this, this is the error of A. So look at this is the 0.5 by 2.5 plus, look at this is the 0.01 divided by, this is the 1.10. So look at this is the 1 by 5 plus this is the 1 by 10. So look at this, the 10 is the LCM. So this is the 2 plus 1. So this is the 3 by 10. Now we have to calculate AB. Look at this is the 2.5 into this is the 1.0. So this is the 0.25. Now delta y by y, this equals to 3 by 10. So look at this, delta y equal to, this is the 3 by 10 into 0.25. So look at this is the 0.075. So look at this is the 0.08. So error is the 0.08, time is the, look at this 0.25. So option A is correct. Okay. Now question number 2.8. You measure two quantities A equal to 1 meter plus minus 0.2 meter. B equal to 2 meter plus minus 0.2 meter. We should report the correct value of root under AB. So look at this, suppose x equals to, this is the root under AB. Now root under AB means, look at this is the 1 into 2. So look at this is the root 2. So this is the 1.4. Okay, no problem. Now next, look at this, A has two significant figure, B also has two significant figure. So x also has two significant figure. So look at this is wrong. Okay. Now look at this, here delta x by x equal to, look at the root over means power half. So look at this, half into, this is the delta A by A plus this is the also half into delta B by B. Now half into delta A by A, look at this. So look at this is the half into 0.2 by 1 plus half into, this is the 0.2 by 2. So look at this is the 1 by 10 plus, look at this is the 1 by 20. Now 20 is the LCM. So 2 plus 1, this is the 3 by 20. Okay, no problem. Now we have to calculate delta x. Look at this here, delta x equals to, this is the 3 by 20 into x. What is the x? X is the 1.4. So look at this is the 4.2 by 20. So look at this. This is the 0.21. 0.21 means this is the 0.2 because it has one decimal places. So error also have one decimal places. Look at this. Option D is correct. Okay. Now look at this question number 29. Which one of the following measurements is most precise? Look at this, the minimum measurement. Look at this, the least value of measurement is the precise measurement. So look at this is the 5.00 millimeter. Look at this is the 5.00 centimeter. So look at this measurement is less than this. Now this less than this less than this. So is the most precise measurement. Now question number 2.10. The mean length of an object is 5 centimeter. Which of the following measurement is the most accurate? Look at this. 5 minus 0.444, 5 minus 5 minus 4.9, so this is the 0.1 centimeter. 5 minus 4.8, so this is the more than 0.1. This also more than 0.1. This also more than 0.1. So look at this. This is the most accurate measurement. Okay. Next. Now 2.11. Young modulus of steel is 1.9 into 10 to the power 11 Newton per meter square. When expressed in CGS unit of dynes per centimeter square, it will be equal to. Now look at this. This is the 1.9 into 10 to the power 11 Newton per meter square. Now 1 Newton means 10 to the power 5 dyne. So look at this 10 to the power 5 dyne. Okay, no problem. Now 1 meter square equal to 10 to the power 4 centimeter square. So look at this and this. This is the 10. Therefore, this is the 1.9 into 10 to the power 12 dyne per centimeter square. Okay, look at this. Option C is correct. Now question 2.1. If momentum P, area A and time T are the taken to be the fundamental quantities, then energy has the dimensional formula. Now look at this. Energy E can be expressed in terms of momentum, area and time. Okay. So look at this. Energy E equal to momentum to the power A, area to the power B and time T to the power C. This is equation number 1. Now what is the dimension of energy? Means work done. So this is the ml squared T minus 2. Okay. Now what is the dimensional formula for momentum? ml T minus 1. So look at this. This is the ml T minus 1. No problem. Okay. Now area means length into breadth. So L into L means L square. So look at this. This is the L square to the power B. And this is the T to the power C. So look at this. This is the M to the power A, L to the power A plus 2B, T to the power minus A plus C. Okay. Look at this. So here ml squared T minus 1. Okay. Now applying the principle of dimensional homogeneity, we can get, look at this, A equal to 1 because dimension of LHS equal to dimension of RHS. So power of MA equal to power of M, power of L equals to power of L. Now A plus 2B, this equal to 2. And minus A plus C, this equal to minus 2. Now A equal to 1. So look at this. This is the 1 plus 2B. This equals to 2. Therefore 2B equal to 1. So B equal to half. Now minus A. Now minus A equal to minus 1 plus C equal to minus 2. So C equal to minus 1. Okay. So now if we put the value of ABC in equation 1, therefore E equal to, look at this, this is the P to the power 1, A to the power half and T to the power minus 1. Okay, understood? Now question number 2.13. On the basis of dimension, decide which of the following relations for the displacement of particle undergoing simple harmonic motion is not correct. You know, equation of simple harmonic motion y equal to a sine, this is the omega t. Omega t is the angle, a is the displacement, a, a is the amplitude, and x is the displacement. Now look at this here, 2 pi t by t, this is the dimensionless. So this is the correct. Sine is also dimensionless. So this also correct. Now this is the amplitude, this is the y same dimension. So A is the correct equation of ACHM. Okay. Now look at this here, y equal to a vt. V has dimension lt minus 1 and t has t. So look at this is the L. But we know angle has no dimension, but here angle has dimension all. So this is incorrect statement. Now look at this also dimension. So this is also incorrect. But look at this equation and this equation are alike. Therefore, this also represents the equation of ACHM. But question is not correct. So look at this, B and C are not correct. So our options is B and C. Okay. Now question number 2.14. If P, Q and R physical quantities having different dimensions, which of the following combinations can never be a meaningful quantities? Look at this, P minus Q. Two different physical quantities are not be subtracted. So this is the incorrect statement. PQ minus R may be valid if the product of PQ has same dimension as that of R. Now look at this C. PQ by R, yes, it is possible because two different dimensions can be multiplied or divided. Now look at this, PR minus Q square by R. Look at this, P into R has dimension as that of Q square, so it is possible. But look at this, R plus Q by P not possible because R and Q are different physical quantities, so it is not possible. Now question number 2.15. Photon is quantum of radiation which energy equal to h nu. Nu is the frequency and h is the Planck's constant. The dimensions of h is same as that of. Now from here the dimension of h, the dimension of energy by dimension of nu. So look at this is the ml square t minus 2 by this is the t minus 1. So this is the ml square t minus 1. Okay, no problem. Now look at this, linear impulse has dimension ml t minus 1. Angular impulse has same dimension as that of Planck's constant, and angular momentum also has same dimension as that of Planck's constant. So look at this, option B and option D are correct. Okay. Now question number 2.16. If Planck's constant h, speed of light in vacuum c are taken two fundamental quantities, which one of the following can in addition be taken to express length, mass and time in terms of three chosen fundamental quantities? Look at this, mass of electron. Yes, mass of electron can be taken to express length with the help of h, c and mass. Mass of proton, yes, mass of proton and h and c can be used to express mass. Okay, now universal gravitational constant, yes, universal gravitational constants also be used to express mass, length, time with h and c. Okay, now charge of electron, look at this, charge of electron is the A into T. So this physical quantity is not used to express length, mass, time with the help of H, C and charge of electron. So look at this here, A correct, B correct and D are correct. Okay. Now question 2.17. Which of the following ratios express pressure? Look at this. pressure means force by area. So look at this. This is the correct. Energy by volume, that is energy density, is also expressed in terms of pressure. Now energy by area, no. So energy by area cannot be used to express pressure. Force by volume also are not used to express the pressure. Okay. Now 2.18. Which of the following are not the unit of time? Look at this. Second is the unit of time. Parsec is the unit of length. Year is the unit of time. Light year is the unit of length. So look at this. Parsec and light year are not the unit of time. Now look at this VSA. Very short answer question. Why do we have different units for the same physical quantity? For different magnitude of a physical quantity, different units are chosen. Such as to measure the mass of atom, we measure AMU. To measure the football, you used gram. To measure the mass of a truck, we use metric ton. So different unit of same physical quantity are unit. Now 2.20. The radius of an atom is of the order of 1 angstrom. How many magnitude higher is the volume of atom as compared to the volume of nucleus? Okay. Now volume of atom by volume of nucleus. This is the 4/3 pi. This is the R atom whole cube divided by 4/3 pi. Eta R nucleus cube. Now this and this cancel out. So look at this 10 to the power minus 10 by 10 to the power minus 15 whole cube. So look at this. This is the 10 to the power 15. Okay. Now 2.21. Name the device used to measuring the mass of an atom and nucleus. Mass spectrograph is the instrument which measures the mass of an atom and molecules. Now question 2.22. Express the unified atomic mass unit in kg. Now look at this. 1 AMU equal to 1 by 12 part of mass of carbon C isotope. Look at this. This equals to 1 by 12 into, this is the 12 into 10 to the power minus 3 whole divided by Avogadro number. What is the Avogadro number? 6.023 into 10 to the power 23. This becomes 1.66 into 10 to the power minus 27 kg. Okay, no problem. Now 2.24. Why the length, mass and time are chosen as the base physical quantity in mechanics? As length, mass and time are independent of each other, that is why they are taken as the fundamental or base physical quantities. Okay. Now essay, that is short answer type question. Now 2.25. The earth moon distance is about 60 earth radius. What will be the diameter of the earth as seen from the moon? Look at this. Suppose this is the earth. Okay. Now this is the diameter of earth. Okay. Now this is the position of moon. Moon is seen from, now the earth is seen from here. Okay. Earth is seen from here. So look at this. This is the, now look at this here. Angle is theta. Okay. Here angle is theta. So theta equal to arc length. Arc length, that is the diameter. Diameter is the 2r divided by, this is the 60r. Now look at this. Now so this is the 1 by 30. Now 1 by 30 radian is the theta. So this is the 1 by 80 divided by 3.14. So look at this. This is the 6 by 3.14. So this is the almost 2 degree is the angle made by the earth diameter from the moon. Okay. Now moon is seen half degree diameter from the earth. Okay. So look at this. If moon seen half degree, so look at this diameter of earth by diameter of moon. This is the 2 degree by half degree. So look at this ratio becomes 4. That is diameter of earth is 4 times more than the diameter of moon. Okay. Now see. From parallax measurement, sun is found to be a distance about 400 earth radius. So look at this distance d equal to this is the 400 earth. No problem. Estimate the ratio of the sun and earth diameter. Okay. Now look at this. You know the diameter of earth by diameter of moon. This is the 4. Okay. Now we have to calculate diameter of sun by diameter of this is the earth. This is the question mark. Okay. Now you know half degree equals to diameter of sun by distance of sun from the earth, RS, equal to diameter of moon divided by this is the distance of moon from the earth. Okay. So look at this. Now look at this. So d sun by d moon, this equal to look at this. This is the RS divided by this is the RM. Okay. Look at this. This is the 400. Okay. Now look at this here. ds by dm into dm by dr. This equals to this is the 400 into look at this here de by dm equal to 4. So dm by d equal to 1 by 4. Therefore this and this is the 100. This and this cancel out. So diameter of sun by diameter of earth equal to 1 by 100. Okay, understood? Now 2.26. Which of the following time measuring device is most precise? A wall clock, a stopwatch. Look at this wall clock measures minimum time 1 second. A stopwatch is measure the fraction of second. Okay. A digital watch also measures fraction of second, but an atomic clock measures very small time. So look at this. This is the most precise instrument for measuring the time. Now 2.27. The distance of a galaxy is of the order of 10 to the power 25 meter. Calculate the order of magnitude of time taken by the light to reach from the galaxy. Look at this time taken t equal to this is the distance by speed. Look at this distance is the 10 to the power 25 whole divided by look at this is the 3 into 10 to the power 8. So look at this is the 1 by 3 into 10 to the power 17 second is the time required to reach the light from galaxy to our earth system. Now question number 2.28. The Vernier scale of a traveling microscope has 50 divisions. That is capital N is equal to 50. Okay. Which coincides with 49 main scale divisions. Okay. So VC equal to look at this 1 MSD main scale division minus 1 VSD. Okay. No problem. Each of the main scale division is 0.5 millimeter. So look at this. This is the 0.5 mm minus, look at this, 50 divisions of MSD equals to 50 VSD is equal to 49 MSD. So 1 VSD equals to 49 by 50 VSD. So 1 VSD equal to 49 by 50 MSD. So look at this. This is the 49 by 50 into this is the 0.5. So look at this. This is the 0.5 into 1 minus 1 by 50. Okay. So look at this. This becomes this is the 0.5 by 50. So look at this. This is the 0.01 mm. Okay. Calculate the minimum inaccuracy of the measurement. Look at this. The minimum inaccuracy of the measurement is the VC. That is least count. So answer is 0.01 millimeter. Okay. Now 2.30. If the unit of force is 100 Newton, unit of length is 10 meter, unit of time is 100 second, what is the unit of mass in this system of units? Look at this, we know the dimension of force is equal to, this is the mlt minus 2. From this relation, we can calculate m is equal to, this is the m L minus 1 T square is the dimension of force in terms of force, length and time as a fundamental quantities. Okay. Now the value of a physical quantity always remains same, that is N1 U1 equals to N2 U. Okay. So look at this. This is the SI value and this is the SI units. Okay. This is the value in new systems and this is the unit in new systems. Okay. Now look at this. So look at this N2 by N1. So this is the U1 by U2. Okay. Therefore, look at this. Therefore, this is the F1 by F2. Okay. No problem. This is the L1 by L2 to the power minus 1 and this is the T1 by T2 whole square. Okay. Now in SI system, the value of mass is 1 kg. Okay. Now look at this, F1 is the 1 Newton, F2 is the 100 Newton. Okay. Now L1, this is the 1 meter and L2 is the 10 meter to the power minus 1. Okay. T1, this is the 1 second and T2 is the 100 second square. Okay. No problem. So look at this. This is the 1 by 100 into 10 into 1 by 10 to the power 4. This and this cancel out. So look at this, 10 to the power minus 5. Therefore, N2 is equal to 10 to the power minus 5 kg. Okay, understood? So, unit of mass is 10 to the power minus 5 kg. Now, look at this question number 2.31. Give an example of a physical quantity which has unit but no dimension. The physical quantity angle and solid angle has unit but no dimension. Next, a physical quantity which has neither unit nor dimension. Okay, specific gravity, Poisson ratio, etc. are the physical quantity which has neither dimension nor unit. Okay. Now, question number 3. A constant which has unit. Look at this. The gravitational constant G has unit Newton meter square kg to the power minus 2. Okay. Now, the constant which has no unit, Reynolds number is a constant which has no unit. Okay. Now, 2.32. Calculate the length of arc of a circle of radius 31.0 centimeter which subtend an angle of pi by 6 at the center. Okay. Now, look at this. This is a circular path. Okay. Now, angle made at the center, this is the, look at this is the pi by 6. We have to calculate the arc length. Now, we know theta equals to arc length by radius. Here, radius is equal to 31.0. So, look at this is the pi by 6 equal to s divided by 31.0. Therefore, s equal to This is the 31.0 into pi. Pi is the 3.14 divided by 6. Now, so length of the arc, look at this, length of the arc almost, this is the half, so almost this is the 50, this is the almost 16 centimeter. Okay. Now question number 2.3. Calculate the solid angle subtended by the periphery of an area of 1 centimeter square at a point situated symmetrically at a distance of 5 centimeter square from the from the area from the from the area. Okay. Now solid angle equal to, look at this, ds by r square. Okay. Now ds is equal to, this is the 1 centimeter square, r is the 5, so look at this is the 5 square. So look at this is the 1 by 25 steradian. Okay. Now question number 2.34. The displacement of a progressive wave is represented by y equal to a sine omega t minus kx. Okay, where x is the distance and t is the time. Write the dimensional formula of omega and k. Now look at this. This is the angle. So angle is dimensionless. Therefore omega t equal to 1. So omega equal to t minus 1. Same way kx is also the angle. Kx is dimensionless. So kl equal to 1. So dimension of k is l minus 1. Okay, understood? Look at this 2.35. The time for 20 oscillation of pendulum is measured as T1 equal to, look at this, 39.6 seconds. T2 equal to 39.9 seconds. And T3 equal to 35.5 seconds. What is the precision in the measurement? What is the accuracy of the measurement? Okay. Now we know the precision of the measurement is equal to least count. Now from this measurement it is obvious that the least count is equal to 0.1 second. So precision for 20 oscillation is equal to, this is the 0.1 second. So precision for one oscillation, this is the 0.1 divided by 20. So look at this is the 0.005 second per oscillation. Okay. Now we know the time period of second pendulum t equal to 2 seconds. Now we have to calculate time period. Now we have to calculate average time period of these observations. Okay, the mean value of measurement t dash, this equal to, look at this is the 39.6 plus this is the 39.9 plus this is the 39.5 divided by 3. Okay, no problem. Now look at this, 0.6 plus 0.9, this is the 1.5, 1.5 plus this is the 0.5, so 2 divided by 3, so look at this is the 39.66. Okay. Now look at this is the time for, this is the average time for 20 oscillation. So t dash by 20, this equal to, look at this is the 3.966 by 2. Okay. So look, now this equal to 1.983. So look at this equals to 1.98. Now the accurate measurement t dash, this equals to 2 minus 0.005. So look at this is the 1.995. Okay, so error in the measurement, look at this minus this. So look at this is the 1.995 delta t equal to minus 1.98. Okay, so look at this is 0.015 is the error in measurement in each oscillation. Okay. 2.36. A new system of units is proposed in which the unit of mass is alpha kg, unit of length is beta meter, and unit of time is gamma second. how much will 5 joule measures in this new system. Okay. Now look at this. Here N1 U1 equals to N2 U. Okay, no problem. Therefore, look at this N2 by N1. This equals to U1 by U. Okay. Now look at this. Here N1 is equal to, look at this, here N1 is equal to 5 joule. Okay. Now N2 is the question mark. So look at this. This is the N2 by N1. This equal to, this is the, now 5 joule is the unit of energy. So U1 is the M1 L1 square T1 minus 2. And M2 here L2 square T2 minus 2. Therefore, this is the M1 by M2, okay, into L1 by L2 whole square, and this is the T1 by T2 to the power minus 2. Put the values. M1 is the kg, M2 is the, look at this, alpha kg. Okay, look at this. Here L1 is the meter and this is the beta meter square. Okay. Now T1 is the second and this is the gamma second to the power minus 2. And N2, this is the N2, but this is the 5 joule. Okay. So look at this, N2 is equal to, look at this, this is the, this cancel out. So this is the 5 alpha to the power minus 1, beta to the power minus 2, gamma square. Okay. Next. One. Now 2.37. The volume of liquid flowing per second of a pipe of length L and radius R is written as this. Okay. Now look at this. P is the pressure difference between the two ends of the pipe. Eta is the coefficient of viscosity of the liquid having dimensional formula this. Okay. Check whether the equation is dimensionally correct or incorrect. Look at this. Dimension of LHS. Look at this. The dimension of LHS is the volume of liquid flowing per second. Okay. So look at this. This is the L cube T. So look at this. This is the L cube T minus 1. Now dimension of RHS. Look at this. The dimension of RHS. Dimension of pressure. This is the M L minus 1 T minus 2. Radius to the power 4, that is the R to the power L to the power 4, and eta is the M L minus 1 T minus 1. Okay, and L is the length. Okay, no problem. Now look at this. This is the L minus 1, L minus 1 cancel out. This L and this L to the power 4, so this is the L cube. M cancel out, and this is the T minus 1. So look at this. This is the L cube T minus 1, as dimension of LHS is equal to dimension of RHS. So the equation is correct. Look at this. A physical quantity X is related to four measurable quantities A, B, C, D as follows. Where X equal to this. The percentage error of A, B, C and D are given. We have to calculate the percentage error of X. Now look at this. The relative error of X, that is delta X by X, equals to 2 into, this is the delta A by A, plus this is the 3 into delta B by B, plus 5 by 2, this is the delta C by C, plus 2 into delta D by D. No problem. So look at this. This is the 2 into 1%. Okay. Plus this is the 3 into, this is the delta B by B. This is the 2%. Okay. And look at this. This is the 5 by 2 into 3%. And this is 2 into 4%. Okay. So look at this. This is the 2% plus 6% plus 7.5% plus this is the 8%. Now 2 plus 6, 8, 8 plus 8, 16, 16 plus 7.5. So this is the 23.5% is the error in measurement of X. Okay. If the above value of x is calculated on the basis of the above relation is 2.763, what value should you round up the result? Now look at this. So now we get delta x by x. This equal to 23.5%. So this becomes 0.235%. Therefore, look at this. This is the 0.24. So significant digit of the absolute error of x is the 0.24. So significant figure of the value of x has 2. Now 2.763 can be rounded as 2.8. Okay. Now look at this 2.39. In the expression p equal to a l square m to the power minus 5 g to the power minus 2 is the energy, m is the mass, l is the angular momentum, g denotes the gravitational constant. So that p is dimensionless. Now look at this. P is equal to, look at this, this is the energy, the dimension of energy m l square t minus 2. Okay, no problem. The dimension of angular momentum m l square t minus 1. Look at this to the power 2. Mass to the power minus 5. And g, this is the m minus 1 l cube t minus 2 whole to the power, this is the minus 2. Now look at this here, power of m. Look at this power of m, this is the 1, this is the 2, this is the minus 5, and this is the plus 2. So look at this 1 plus 2 minus 5 plus 2. L, what is the power of L? Look at this power of L here, this is the 2 plus here, this is the 4, no problem. And here look at this is the minus 6. Okay. Now power of t, look at this, the power of t, look at this is the minus 2, this is the minus 2, and this is the plus 4. Okay, no problem. So look at this, p is equal to m to the power 0, l to the power 0, t to the power 0. So look at this, p is dimensionless. Okay. Now 2.40. If the velocity of light c, Planck's constant h, gravitational constant g are taken as a fundamental quantity, then express the mass, length and time in terms of these quantities. Okay. Now mass can be expressed in terms of velocity of light, Planck's constant, okay, and gravitational constant capital G. Okay. This equation number 1. Now put the dimension of M, C, H and G. Look at this. This is the M, L to the power 0, T to the power 0. This equal to, look at this. This is the LT minus 1 to the power x. No problem. H. This is the ML square T minus 1 to the power y. Okay. And G, look at this is the m minus 1 l cube p minus 2, this to the power z. So look at this equals to, look at this is the m to the power, this is y and this is minus z. So this is the y minus z. L to the power, look at this is the x, this is the 2y and this is the 3z. Now t to the power, look at this, t to the power, this is the minus x, this is the minus y and this is the minus 2. Now applying the principle of dimensional homogeneity. Look at this here, m to the power 1. So look at this, y minus z equal to 1. Okay, this is equation 1. Now this is the x plus 2y plus 3z, this equal to 0. And finally, look at this, minus x, minus y, minus 2z, this also 0. So look at this, x plus y plus 2z, this equal to 0. Okay. Now look at this, if we add this plus this, okay, this is equation number 1, this is equation 2 and this is equation 3. Okay, no problem. Now look at this 2 plus 3. Okay, equation 2 plus equation 3. We get, look at this, x and x cancel out. So look at this y plus z, this equal to 0. So y equal to minus z. If y equal to minus z, so look at this is the minus z equal to 1. So look at this is the minus 2z equal to 1. So z equal to minus half. If z equal to minus half, then y equal to minus z, so y equal to half. Now look at this, we have to calculate y from this equation. Look at this, here x plus 2y, that is 2 into half, plus 3z. So look at this, 3 into this is the minus half, this equal to 0. Therefore x plus 1 minus this is the 3 by 2 equal to 0. So x equal to half. Now if we put the value of x, y, z, we get, look at this is the m equal to c to the power x. So look at this, c to the power half. H to the power, look at this is the half. And g to the power, this is the minus half. Okay, understood? Now in the same way, we can calculate the dimension of length. Look at this, here m is replaced by l. Okay, so look at this is the l. So dimension of, look at this, the dimension of length, this is the m to the power 0, this is the l to the power 1. If l to the power 1, so look at this, here this equal to 1. Okay, and look at this, y minus z equal to 0. So look at this, here y equal to z. If y equal to z, put here, this is the, look at this, minus x, this is the minus z, and this is the 2z equal to 0. So x equal to minus 3z. No problem. Now put the value of y and x. Look at this, here x equals to minus 3z. Y equal to z. So look at this is the 2z plus 3z. This equal to 1. This and this cancel out. So look at this, z equal to half. If z equal to half, x equals to minus, this is the 3 by 2. And y also half. So look at this, length is, so dimension of length, this is the, look at this, c to the power minus 3 by 2. This is the h to the power half, and this is the g to the power half. Okay, understood? Next. Now to express time, this l can be replaced by, this is the time t. So dimension of this is the t to the power 1. Look at this, y minus z to the power 0. This is the x plus 2y minus 3z, this also 0. And look at this equal to 1. Okay. So look at this, from here, this is the y equal to z. If y equal to z, look at this, you put y equal to z, look at this, x plus this is the 2z plus 3z equal to 0. So x equals to minus 5z. Now put here, look at this, x equals to minus 5z. So look at this is the 5z. Y equal to z. So look at this is the minus z. Minus 2z equal to 1. So look at this is the 2z equal to 1. So z equal to half. If z equal to half, x equals to minus 5 by 2 and y equal to half. Therefore time t equal to, look at this is the c to the power minus 5 by 2. H to the power, look at this is the half, and g to the power is also half. Okay, understood? Next. Now last question, 2.41. An artificial satellite is revolving around a planet of mass capital and radius r in a circular orbit of radius smaller. From Kepler's third law about the period of a satellite around a common central body, square of the period of revolution is proportional to the cube of the radius. So, using the dimensional analysis, that the t equal to k by r root under of r cube by g. where k is dimensionless constant and g is the acceleration due to gravity. Look at this. The square of period of revolution, okay, is proportional to the cube of the radius of the orbit. That is t square proportionate r cube. Okay. Therefore, t proportionate r to the power 3 by 2. Now, the period of revolution also depends on radius of the planet and acceleration due to gravity. Okay. So, look at this. T equal to k, here r to the power 3 by 2 plus capital R to the power a into g to the power b, where a and b are the indices and k is dimensionless constant. Now look at this. What is the dimension of period? The dimension of period, this is the m naught, n naught, p. Okay. Now look at this. K is the dimensionless. Here dimension of r, this is the L. So this is the L to the power 3 by 2. Okay. Now dimension of radius, this also L. So look at this L to the power a. Now g, look at this, g is the L to the power, g has dimension LT minus 2. So look at this is the p. Therefore, look at this, here L to the power, this is the 3 by 2 plus a plus b, and t to the power, look at this is the only minus 2b. Now applying the principle of dimensional homogeneity, that means the dimension of LHS is equal to dimension of RHS. So look at this, power of L equals to power of L, here 3 by 2 plus a plus b equal to 0. Again look at this, minus 2b equal to 1, because power of t is equal to power of t. Okay. So b equal to, this is the minus half. Now this is the 3 by 2 plus a minus half equal to 0. So 1 plus a equal to 0. So a equal to minus 1. No problem. Now putting the value of a and b, we can get t equals to, look at this, this is the k to the power k into r to the power 3 by 2 into r to the power minus 1 and g to the power, this is the minus r. So look at this, t equal to a by r root over, this is the r cube by g, is the expression of period of revolution of a satellite. Okay. Many thanks for watching this video. This video will be extremely helpful for your preparation in NEET, Main and Advanced. Please like, share, comment on it. And if you are new, don't forget to subscribe my channel to get the best score in NEET, Main and Advanced. Okay.